Angular friction. Suppose we consider an object of mass m is on a horizontal surface. The weight of the body mg is acting vertically down. The normal reaction is acting vertically up, as are seeing in the figure. If the applied force is acting along this direction, we know that the frictional force is acting along this direction. Now the resultant of normal reaction and frictional force is along this direction. The angle between these two is known as the angle of friction. The angle of friction is nothing but the angle made by the resultant of normal reaction and frictional force with normal reaction. This is the angle of friction. Now we discuss about the motion of a body along a rough horizontal surface. Suppose we consider an object of mass m is placed on a rough horizontal surface. A force F is applied. Due to this force, the object is moving with acceleration a. When it is moving, the sliding frictional force Fk is acting on the body. Initially, to move this body, the minimum force required is equivalent to a limiting frictional force. If the applied force is more than the limiting frictional force, then only the body can slide. Now we are considering the body is sliding. When it is in motion, the frictional force acting between the surfaces is the kinetic frictional force. In this case, the net force acting on the body is F minus Fk. This is nothing but m into a if the object is moving with acceleration a. Therefore, the acceleration a equal to F minus Fk by m. This is the expression for acceleration when a body is moving on a rough horizontal surface. Now we consider the body is moving on a rough inclined plane. Then what will be the expression for acceleration? Now we consider an inclined plane having inclination theta. When an object of mass m is placed on this, the weight is acting vertically down as are seeing in the figure. This is not normal to the surface. This can be divided into two components. One is mg cos theta, which is normal to the surface, and mg sin theta, parallel to the surface. The normal reaction acting on the mass is opposite to this, which is nothing but mg cos theta, and this component mg sin theta. This is parallel to the surface, and this is the component which helps the body to move down. If there is no friction, simply we can say the body can slide with the force mg sin theta and the acceleration is g sin theta. If the surface is rough, the frictional force is acting. Consider an object is placed on an inclined plane. Suppose we go on increase the inclination of the plane, then what we can observe? Now you take this activity. Suppose if object is like this, can it slide? No. If you go on increase the inclination of the plane, at a particular inclination, the body will slide down. Now this angle where the body starts sliding, this is called the angle of repose. Angle of repose is nothing but angle of inclined plane at which the body starts sliding down. Suppose we consider the angle of repose is alpha. If theta equivalent to alpha, angle of inclined plane is equal to angle of repose, then the body starts sliding. If theta less than alpha, the body is stationary. If theta is greater than alpha, the body slides down easily. Now I am considering the case theta equal to alpha. When theta equal to alpha, the body is ready to slide down. In this case, the pulling force acting on the body is exactly equal to the frictional force. In this case, we are taking the angle of inclination is alpha. In this case, we can write mg sin alpha. This is equal to mu s mg cos alpha. Mg sin alpha is the pulling force and this is equal to mu s mg cos alpha. This is the limiting frictional force. And from this we can write the coefficient of static friction mu s is equal to sin alpha by cos alpha, and this is equal to tan alpha. And alpha, the value of alpha is tan inverse mu s. If there is no friction, simply we can say the body can slide with the force mg sin theta and the acceleration is g sin theta. If the surface is rough, the frictional force is acting. When the body is moving down, the frictional force is acting opposite to this component, opposite to the motion, and here the kinetic frictional force Fk is given by mu k into r, and this is equal to mu k into mg cos theta, since the normal reaction is mg cos theta. When the body is sliding down with acceleration a, the net force acting on the body is mg sin theta minus mu k mg cos theta. Therefore, the acceleration a equal to g into sin theta minus mu k cos theta. Suppose if the body is moving up. Now we try to write equation for acceleration when an object is moving up an inclined plane. In this case, one, it is moving up. Since the motion is along this direction, that is upwards, the frictional force is acting opposite to this. The pulling force of this block mg sin theta as well the frictional force both are acting opposite to the motion. Therefore, the minimum force required to move this body up is mg sin theta plus frictional force Fk. Therefore, F equal to mg sin theta plus mu k mg cos theta. If this force is applied, the body moves up with uniform velocity. Why? Because this is the minimum force required to move the body up.